This video is the most exciting because this is where all that you've learned with trigonometry comes together. I'm going to teach you your trig functions and how to find their values on the unit circle. This is it. This is what you've been waiting for, applying trig functions to everything that you have learned so far. And if there's anything you've missed, make sure you go back and check my other videos in this playlist to learn all you need about trigonometry, how to label a unit circle, degrees, radians, everything. But now we're going to put it all together, and this is the most exciting part. Maybe not for you, but this is where I feel like it all comes together and it can be a little bit of fun. So let's learn some trig functions and find out what they mean and help you understand trigonometry. So the first thing you have to know is, what are these words? You have sine, cosine, and tangent. Now they have abbreviations. Sine is written as sin, really, but that's pronounced sine with a long I. Cosine is just written as COS, stands for cosine, again, long I. And tangent is written as tan. And maybe you've heard this abbreviation, SOHCAHTOA, before. What in the world does that mean? Let me show you. So let's see what this stands for. We're going to do the blue one first. So S stands for sine, and it equals O is opposite over hypotenuse. So what you have here is your S is for your sine, your O is for your opposite, and your H is for your hypotenuse. So that's where the SO part comes from. Now let's talk about the second part, the CA. So the C is going to stand for cosine, and that's going to equal, the A is for adjacent, and the H is again for hypotenuse. So your C is for your cosine, your A is for your adjacent, and your H is for your hypotenuse. Okay, now we just have one more to figure out. Now we're on to TOA. T stands for tangent. Your O is for opposite. And your A is for adjacent. So your T is for your tangent, your O is for opposite, and your A is for adjacent. This is something you're definitely going to need to know. So put this on a bright colored sheet of paper, write it in colors, surround it in highlighter, whatever you need to do to make sure you remember this, because it's something you will use all the time. Now that we know what the trig functions stand for and how to find them, we're going to apply it to our unit circle using radians and degrees. If you're not sure on how to do that, make sure you check out my previous video on how to label these radians on your unit circle with the ratios. So in this example, we want pi over 4 on the unit circle. So let's go ahead and draw pi over 4. We know that's right here. Here's our triangle. This is pi over 4, which makes our degrees 45, which makes our ratios 1, 1, square root of 2. Again, if you're not sure how to do all that as quickly as I did, check out my other videos. It'll show you exactly how we got this. So now we want sine of pi over 4. So in your mind, I want you to remember, here's your thought bubble, sine is opposite over hypotenuse. So what is our opposite? You're like, opposite of what? You are always standing in the origin, okay? So this is where you're standing. This is you. You're feeling a little green today. And you're always standing here. So what is opposite of where you are? Right there, that 1. So your opposite is 1, and your hypotenuse. Well, you always know the hypotenuse is across from 90 degrees, so square root of 2. So for sine of pi over 4, your answer is 1 over square root of 2. Now let's do cosine of pi over 4. Again, so in your mind, you want to think, okay, cosine is adjacent over hypotenuse. So again, my adjacent side. Where am I? That's right, you're in the origin. You're always standing here. So what is adjacent to you? What is next to you? This 1 right here is next to you. So 1 is your next to, and your hypotenuse is square root of 2. So look at that. Sine and cosine of pi over 4 are exactly the same answer. Imagine that. Now let's look at tangent of pi over 4. Tangent of pi over 4, okay, in your thought bubble, you got to think tangent is opposite over adjacent. So what is your opposite side? Your opposite side is 1. Good. Your adjacent side is 1. So tangent of pi over 4 is just 1. And that is how you label a pi over 4 triangle, label the correct ratios, and find each trig function for that value. Let's try another. Now let's do 5 pi over 6. Okay, so hopefully you all remember that 5 pi over 6 is going to be right here. This is my 5 pi over 6, which makes this a 30-degree angle because it's the pi over 6 family. So I have a 30, 60, 90, and hopefully if you don't remember those ratios, like I said, you can check out my other video, but here are the ratios for a 30, 60, 90 triangle. So across from the 30 is the 1, across from the 60 is the square root of 3, but it's negative because we're on the left side of the origin. So our x values are negative, and our hypotenuse is 2. So again, in your thought bubble, okay, I want sine of pi over 6. Well, sine is opposite over hypotenuse. So my opposite, remember you're always standing here in the origin. This is where you're at. Opposite of you is 1. Hypotenuse is 2. For cosine, okay, cosine is adjacent over hypotenuse. So adjacent side is, right next to you, is negative square root of 3. And your hypotenuse then would be 2. And now for tangent, right, we want to put opposite over adjacent. So our opposite side is 1, and our adjacent side is negative square root of 3. And of course, you can always just write that as negative 1 over square root of 3. Okay? So those would be the 3 trig functions for 5 pi over 6. All right, let's do one more so you have an example of all 3 of the radian families. This one is 4 pi over 3. So hopefully you remember that this spot over here is pi, which would be 3 pi over 3. So 4 pi over 3 is going to be down here, which makes this a pi over 3 family, right? And our pi over 3 family is 60 degrees. This is my 60 degrees. So over here would be square root of 3, but it's negative because we're below the x-axis, so my y values are negative, and my hypotenuse would be 2. Okay, for sine, again, what are your ratios for sine? Do you remember? That's right, opposite over hypotenuse, so your opposite side, remember where are you standing? Always standing in the origin, so your opposite side, negative square root of 3, hypotenuse is 2. Your cosine, okay, in your thought bubble, what are your ratios? Yep, adjacent over hypotenuse. So your adjacent side, what's next to you, negative 1 is next to me, and 2 is my hypotenuse. Okay, last one, tangent. Thought bubble, let's think about it. Tangent is opposite over adjacent, so opposite, negative square root of 3, over negative 1, my adjacent side, so we have a positive square root of 3 for my tangent of 4 pi over 3. So hopefully these examples helped you realize how to label each radian family, pi over 4, pi over 3, and pi over 6, and where to put it around in the unit circle. Now, let's try something that is maybe a little different or that you can't draw a triangle with. So we're going to go back to the unit circle real quick. I want you to label all of your coordinate points and all of the points in radians. So this point over here is 1, 0. Up here, 0, 1. To the left, negative 1, 0. And to the bottom, 0, negative 1, right? These are just our x, y values. We know that we start at 0. Up here is pi over 2. To the left, we have pi. Down here, we have 3 pi over 2. And to the very right, 2 pi. So these are all the coordinate points and our radians at those points. How do you find sine of pi over 2? Well, sine of pi over 2 is up here at the top. How do you draw a triangle for that and label with the ratios when you know that pi over 2 is 90 degrees itself? That's the question. So, gotta teach you something else. Here's what you need to know. We can't make a triangle, but what we're gonna use is the coordinate points at those radian values. So here's what you need to know. Cosine of alpha is x, and sine of alpha is y. Now, what is alpha? This symbol right here, it stands for alpha. It's a Greek letter. It's basically a variable for degrees or radians. So it's your unknown value, okay? That's all that symbol means. It's a Greek letter, it's alpha. It just means unknown value, like if we would say x. But because we're using coordinate points of x, y, we need to use another variable so we're not confused. So cosine is going to be your x value, and sine is going to be your y value. So let's go back. If sine of pi over 2, okay, so sine, again, remember, sine is going to be my y value. What is my y value at pi over 2? That's right. This guy is just going to equal 1. So sine of pi over 2 equals 1. Okay, now what's cosine? So cosine, remember in your thought bubble, okay, cosine is my x value. So what is my x value at pi over 2? Cosine is 0. So that's how you can easily find sine and cosine. How do we find tangent? Great question. There are a couple different ways that you can find tangent. Let me show them to you. First, if you're using SOHCAHTOA, remember tangent is opposite over adjacent, right? That's this part right there. Pretty simple. But if we're using sine and cosine, let's think about this. In SOHCAHTOA, which one uses the opposite? This one right here, right? That's sine. So this is going to be sine in your numerator and cosine in your denominator, because cosine is the one that uses adjacent. But if we're using x, y coordinates, this would be, remember, sine is your y value and cosine is your x. So these are 3 different ways that you can find out what tangent is. Again, this is super important. Put it in your notes, save this information, make sure it's easily accessible. You need to know all 3 different ways that you can find tangent's values. So now let's go back and find tangent at pi over 2. So now we need to be able to find tangent at pi over 2. All right, so in your thought bubble, what are you going to think? Well, tangent is my sine over my cosine, which means it's my y over my x value. So what is my y value? Well, my y value is 1. My x value is 0. Oh no! Do you see a problem? Can you divide by 0? No, you can't. So tangent at pi over 2 is actually undefined. And if you were to actually graph tangent on your calculator, you'd see that there's an asymptote there. It's undefined because you can't divide by 0. Now that we figured out what all of those trig functions are for pi over 2, we're going to figure out the trig functions for those other coordinate points. So let's go with 0, because guess what? Everything that happens at 0 is going to be the same as 2 pi, because they're at the same location. So let's do this. Sine of 0 equals, remember, sine is your y. My y value is 0, which means sine at 2 pi is also going to be 0. Let's do cosine. Cosine at 0 is going to be 1, because that's my x value, right? When you think cosine, remember, you got to think he's your x. And so cosine at 2 pi is also going to be 1. Now let's do tangent. Tangent at 0. Remember, tangent at 0 is going to be your sine value over your cosine value. So 0 over 1. Can you do this problem with 0 in the numerator? Yes, you can. This is just going to be 0. Okay, and how do you remember which one is undefined and which one is 0? Here's a quick trick. If you have 0 over some number and you read it downwards, it says on. Yeah, man, that's on. We can do that one. It's 0. But if you were to have some number over 0 and you read it down, this says no, I'm no good. We can't do this. This is undefined. So this is a quick way to help you try to remember when zero's in the numerator, your answer will be 0. But when zero's in the denominator, it's no good. You can't do it. It will be undefined. Okay, so now we've done 0 and 2 pi, and we've already done pi over 2. So now we're going to do all these trig functions at pi. So sine at pi, remember sine in your thought bubble is your y value. What is your y value at pi? 0. Okay, now we'll do cosine of pi. And remember, cosine in your mind, you gotta be thinking is x. Your x value is -1. And now we do tangent at pi. And remember, your tangent value is y over x. 0 over -1, which gives you 0. Because remember, O is on top, over some number n, on. Yeah, man, I'm on. I can do this. 0. Okay? So those are your 3 trig functions at pi. Let's do the last one at 3 pi over 2. So now let's do all 3 trig functions at 3 pi over 2. So sine at 3 pi over 2. Remember, sine is your y value. So what's my y value here? Y value is -1. Now we do cosine at 3 pi over 2. Remember, your cosine is your x value. My x value here hasn't moved, so it's 0. Tangent at 3 pi over 2. So remember, tangent is going to be my y over my x. So my y value is -1. My x value is 0. You read that down, it says, no, I am no good. Because the 0's on the bottom. Can't do it, it will be undefined. Okay, let's see how this affects your trig functions. If you are in quadrant 1, your cosine is your x values. These are all positive values. Your y values are positive up here, which means your tangent values are also going to be positive. So that means all of the trig functions in quadrant 1 are going to be positive. Let's try quadrant 2. In quadrant 2, your x values are negative. Your y values are still positive, which means tangent is also going to be negative. When you take your y over your x, a positive over a negative will give us a negative, which means the only trig function in this category is sine that will be positive. Your sine values will all be positive in quadrant 2. Let's look at quadrant 3. In quadrant 3, your x values are negative. Your y values are negative. So now let's look at tangent. Tangent is going to be a negative over a negative, which makes tangent positive. So in this category, tangent is the only trig function in quadrant 3 that will be positive. Let's look at the last one. In quadrant 4, your x values are positive, but your y values are negative, which means tangent is also going to be negative again when you have a y, a negative over a positive. So in this quadrant, the only thing positive is cosine. So quadrant 1, all of them are positive. Quadrant 2, sine is positive. Quadrant 3, tangent. In quadrant 4, cosine. You want an easy way to remember this? We're going to come up with an acronym. Here's an easy way to remember. All students take calculus. All of them in quadrant 1, sine in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. So that's an easy way to remember which quadrant and which trig functions will be positive. Hopefully this video helped you put everything together that you have learned for trigonometry. I would love for you to share this video with anyone else that you know that is taking trigonometry, and be sure to subscribe for more videos, especially those on calculus.